Our world is full of diagrams. Graphic representations of everything from the solar system to the hidden origins of life. They have a unique ability to express complex ideas simply, and an intellectual and artistic beauty that has the power to inspire awe and change our perceptions. In the last half-century, one diagrammatic image stands above all others. It represents a scientific breakthrough that's been voted the most significant in the 20th century. More important than penicillin, or the contraceptive pill, or the first working computer.
It's this, the double helix, or to put it another way, the secret of life. This is what our DNA looks like. This sculpture commemorates the fact that nearly 60 years ago, a discovery was made for the very first time of how we are built, how our genes are copied. It was a discovery that paved the way for the mapping of the human genome, cloning, genetic fingerprinting, and could ultimately lead to cures for diseases like cancer. But the double helix has become so well known and loved that we now find it in a whole range of art projects and consumer products across the world. So how did this elegant idea become one of the great scientific discoveries in history? And how on earth did the structure of a human molecule become such a worldwide celebrity?
The discovery in Cambridge of a structure for DNA, the molecule that enables our genes to be passed down the generations, was made in February 1953 by Marcus Crick and James Watson. Whilst others had laboured for years to find the structure, Crick and Watson had a touch of genius and did it in under 18 months. They announced it over a pint in this pub. Their achievement would eventually earn them the Nobel Prize. But the first the wider world knew of it was when Crick and Watson published a short article in Nature magazine. Included in the article was a diagram.
The diagram was created by Francis Crick's wife, Odile, who was a professional artist. Although the original diagram hasn't survived, the article where it appeared has.
DNA was too small to see under a microscope. The physicist Crick and the biologist Watson had worked out that the elusive shape of the molecule had to be a double helix on the basis of X-rays of DNA crystals and the models they built. The challenge for Odile was to create a drawing that captured the three-dimensional shape in a two-dimensional diagram.
So this is the article in Nature where they announce to the world the discovery of the structure of DNA. It's from Saturday, April the 25th, 1953. Here we are. A structure for deoxyribose nucleic acid. The announcement of probably the most important discovery in biology of the last century. But they describe it quite sort of unassumingly. It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism for the genetic material. It's wonderfully understated. Watson later described this as possibly the most famous event in biology since Darwin. What we have here is not only a description of the structure of DNA, but also the way that it makes exact copies of the genes contained inside it. And over on the left here is the diagram that Odile Crick did of the structure of DNA. It expresses everything that's so wonderful about a diagram. It's not a picture of the messy molecular structure. It just gets down to the essence of what's so important about this structure.
According to the American biologist Terry Zinovsky, it may be the most famous scientific drawing of the 20th century in that it defines modern biology.
And what you see are the two ribbons going in a spiral or a sort of helix which will unravel and copy themselves, and the rods between the strands, which are the pairings, this sort of the genetic code that represents. There are also two little arrows which indicate a direction on these strands. Actually, the way the molecule is put together means that each of these strands has a direction, so one goes up and the other goes down. This is the first time the world had ever seen the structure of DNA. It's a breathtakingly original diagram.
Every human cell contains a copy of the human genome, a string of 3 billion molecular components called nucleotides. They're known by the letters A, T, C, and G, and they're linked together by chemical rods. The cell is like a computer. It's programmed so that during reproduction, the double helix unravels. Each strand copies itself, every A pairing up with a T, every C with a G. In this way, a new double helix forms. Because each of us inherits a particular permutation of these pairs, we're all different. What Odile Crick had done was to make this incredibly complicated biological process visible. Odile was a trained artist. She'd studied in Vienna in the 1930s and had then gone on to St Martin's in London and the Royal College of Art. She did occasional portraits of her husband, but most of her work was focused on the female nude. Molecular structures weren't really her thing.
Francis had given her a sketch that he'd made himself so that she would have something in mind when she drew her own. It's not really quite so striking, has a kind of unfinished, rather cluttered look to it. But Odile got the point and turned these rather vague impressions into a memorable image, the power of which she probably didn't realise at the time. Because this double helix has become a symbol not just of DNA or biology or even of scientific discovery. It's become an internationally recognised icon in its own right.
One of the remarkable things about the drawing by Odile Crick is that it has never been bettered. Almost everybody who happened on the double helix in its early days realised that the beauty was part of the proof that it was right. In other words, something this beautiful, this simple, this clear could not be wrong. The structure just fell together in this extraordinary way, and for once, the truth was beautiful. Many people describe Francis Crick as the cleverest man they'd ever met. He had the most tremendous capacity for absorbing material, analysing it, understanding it, and coming through with insights and with questions that drilled to the heart of matters. On the day, 28th of February 1953, when the penny dropped and famously Crick went into the pub and said, "We've discovered the secret of life," he also went back that evening and said to Odile, "I've made a rather important discovery today." And Odile told me that she didn't take any notice of this because he was always saying things like that.
Their collaboration on the actual diagram was quite important. How did that evolve?
Well, when you think about how the discovery was made by Watson and Crick, they then had to sit down and prepare it for publication. And Watson drafted in his sister to do the typing, and Crick drafted in his wife to do the diagram, which was a very good idea because neither of Watson or Crick were any good at drawing themselves. They knew what they'd discovered, but it was quite hard to put it into a simple diagram. But what's beautiful about what she does is that she simplifies it. She takes out the extraneous detail and leaves just a pair of ribbons wrapped around each other, linked by simple rods, which gets across the essential ingredients of the image without going into too much detail.
What sort of impact did the diagram and the paper in Nature have at the time?
It actually was a pretty well a damp squib. Very few people took much notice. The professional biochemists weren't that interested. They didn't think it was important. The geneticists also. This was the spring of 1953. Stalin had just died. The Queen was about to be crowned. Everest was about to be climbed. A lot happened in that spring. The cracking of the secret of life is essentially what it represents, and that took a long time to sink in.
So when did the double helix begin to have an impact on the world's psyche? To understand that, we have to go back to a time before Odile Crick's diagram. Because the surprise of the original discovery had been that something so important and invisible as DNA should turn out to be so beautiful. Molecules hadn't generally been thought to be attractive, so why should this one? The great mystery confronting scientists after World War II was how genes managed to make copies of themselves. Scientists in centres like Cambridge and London had known about DNA for some time. But in the 1940s, they started to ask whether it could be linked to the idea of heredity and gene transmission.
The trouble was, it was very difficult for them to actually see a DNA molecule, establish its structure, understand how it works. Would everything have to be based on hypothesis?
What changed the entire course of events was the research carried out by two scientists working not in Cambridge, but here at King's College in London. Maurice Wilkins and Rosalind Franklin were experimenting with X-ray crystallography. By shining X-rays at DNA samples and creating a pattern of diffracted dots on photographic paper, they hoped to deduce the structure of the molecule. In May 1952, Rosalind Franklin took this photograph, Photo 51, now famous in DNA history. This is the molecule seen from the side. And what the pattern of dots revealed was that the structure must be a spiral, or in scientific terms, a helix.
This is the Crick's house in Cambridge with its characteristic golden helix above the door. When Watson and Crick saw Photo 51, they were galvanised and started trying to create models to create a 3D structure that would explain the evidence in Rosalind Franklin's X-ray. Eventually, they hit on a model that worked. A double helix. Double because the genetic code on one side determined what should be on the other. It was beautifully efficient and explained exactly how DNA copied itself.
This was the secret of life, the mechanism for passing on our genes and creating a new generation. And Odile Crick gave it an elegant simplicity.
I'm kind of fascinated by the question of how this beautiful design has conquered the world and has become, well, the word is rather hackneyed, but iconic. I mean, sure, the science is very important. Crick and Watson won the Nobel Prize in 1962 for the discovery of the structure of DNA. But Rosalind Franklin's photograph number 51 was equally important in the discovery, yet isn't anywhere near as internationally well known. So what is it the public finds so exciting about the double helix?
In the first few years following the breakthrough, it was an image that only circulated within the scientific community. But that changed 5 years later, when the BBC brought the double helix to a wider audience with its first television programme on the subject.
Here you have two chains in the molecule, helical chains running along, one and then the other one running back there.
This episode of Eye on Research was broadcast on the 4th of February 1958.
Having got this structure, does it help us to understand the quite extraordinary things which DNA is able to do in living creatures?
And there were other factors contributing to its growing popularity. From the beginning, the double helix had appealed to artists. One painter who was quick to add it to his palette of scientific metaphors was the surrealist Salvador Dali. He called this his period of nuclear mysticism, and his use of DNA revealed a surprisingly conservative and religious aspect to his art.
Dali does pick it up in the late 50s, which is a really interesting phenomenon. The double helix appears in several of his works, where it really plays a central role. We also know that, Dali more generally was interested in science and took much of his imagination and inspiration from scientific context.
So what do you think Dali was getting at in this picture?
So the title is very difficult to remember, but I think it's desoxyribonucleic acid. So the last bit, it's the easier one. It's just the full name of DNA, desoxyribonucleic acid. And the first part is Dalasi, which is Gala, the name of his wife, and Dali, his own name, intertwined and repeated. Here is the double helix, and this somehow represents life. I think this is actually his wife, Gala, representing here, and somehow the lines combine in her. I think it indicates how he imagines himself and his wife intertwined in this sort of metaphor of life, and that also connects humans with God.
For Dali, DNA was how God influenced the human race, and he even tied it into his belief in the rightness of hereditary monarchy. DNA passed royalty through the bloodline. Dali didn't really care who was on the throne, cretin or genius, good or bad, it was all the same. The legitimacy of the DNA lineage was all that mattered. There's a real irony here. In one sense, the double helix represents the pinnacle of scientific achievement in the modern age, the most famous event in biology since Darwin, as Jim Watson put it. On the other hand, Dali was not the only one to see in DNA a conservatism, an attachment to the past, a sense that we can never be truly revolutionary and make a clean break with history.
If everything was determined by our genes, could anything human be genuinely new? This debate grew in intensity as the science of genetics developed. By the 1990s, scientists were discussing how the human genome could be profiled, the function of each gene identified, and the press started to debate the real implications of the double helix. Was it all good? Would the mapping of the human genome set us free to conquer disease and disability? Or would it prove to be the final confirmation, as Dali had suggested, that everything about us was predestined? Some writers feared that genetics was becoming a new religion, and in two ways.
Like religion, DNA had strict, immutable laws. Were we all predetermined by our DNA? Did that mean that free will no longer existed? And secondly, if DNA could be manipulated to alter or even create a human being, did that mean the double helix was making scientists into gods?
For the writers and artists addressing these questions, the double helix was no longer simply a scientific discovery. It was a metaphor for all human life. An artist who has attempted to visualize these debates for the covers of science magazines is Bill Sanderson. He was asked to illustrate extremely problematic ethical issues. What Bill realized was that there was a striking similarity between the questions DNA raised and ideas explored in the world's classical and religious myths. Perhaps the new dilemmas were, in reality, age-old.
You could use biblical myth and you could use classical myth because they were quite consonant. It actually chimed. The scientists were discussing how much our actions, how much our lives were controlled by this code. So there was one particular one of Moses, I remember, with the 2 tablets on which are engraved the double helix symbols. So in the way that the 2 tablets that Moses brought down were a prescription for existence, then the double helix was prescribing what we were as human beings. There was this element of extra knowledge that was coming to us, that was being imparted to us, that we were digging out for ourselves. In the story of the Garden of Eden is, of course, that with that extra knowledge, we are evicted, as it were, from our innocence. I knew that people would understand the imagery, that the apple of knowledge being proffered by the snake, and what that knowledge does to Adam and Eve. Knowledge gave them the freedom to be human. They could then leave this place of no forward progress, as it were, and go out and suffer, of course, but I mean also that they would investigate.
The wider circulation of the double helix means that it is now a familiar image. People don't necessarily attach a meaning to it, but they see its appeal. And that's made it ripe for commercial exploitation.
I'm not sure what Odile Crick would have made of all of these. Seems like today the double helix can be made into absolutely anything. Here we've got a perfume with a double helix winding down, unsurprisingly called DNA. We've got a lovely tie with a double helix spiralling down the tie. And your dog can even chew on the meaning of life. But my favourite has to be this blow-up double helix. So let's see whether this one spirals the right way.
So, is there a problem when an image of historical importance to science becomes so divorced from its original setting that no one knows what it really is, or what it stands for?
Voila!
There's nothing that can be done about it, if there is. The double helix is an attractive, marketable shape. And what's wrong with that?
The issue for me is whether the global transformation and commercialisation of the double helix has led to confusion. Does it any longer help people to understand how DNA works? Or has its meaning got lost in a wealth of other interpretations that see it not as a symbol of scientific process, but something much vaguer: life, continuity, or essence?
In 2004, advertising took up the double helix and made it the central idea in a campaign for a German car maker. DNA became a metaphor for intrinsic excellence, and it was explored in various forms. One poster featured a double helix with the letters of the slogan "Vorsprung durch Technik" spiralling round in the same way as the lettered bases of the double helix itself. The idea was thought up by Sir John Hegarty and his team. They'd been partly inspired by the 50th anniversary of the discovery of DNA and Odile Crick's diagram of it in Nature magazine.
Every brand, whatever brand you're working on, always has at its heart the kind of DNA. What is it that makes it buzz? What is it that makes it happen? And in a sense, Vorsprung durch Technik is a mystery. And therefore it has a sort of magic around it. Obviously, this is the DNA of the brand. what represents DNA is the double helix. Wouldn't it be wonderful and sort of witty and amusing if we had a group of people trying to extract the DNA out of the car to try and identify what it is that makes this car wonderful? And of course they do. They analyze it, they put it on a piece of film, they look at it, and suddenly it just spells out Vorsprung durch Technik. And I think it's always interesting, actually, when you look at art and science, how you try and visualize an idea, a thought, and trying to visualize DNA as the double helix is quite intriguing, and we were really hijacking that. When you're communicating a great idea, there's always a slight gap where you're trying to get people to fill in the difference. And that's when they connect with it, that's when they have an empathy with the thought, and then it comes alive in their brain. Well, you intrigue people. And I think that's what the double helix does, is you look at it and you begin to get it. You sort of understand it, this complex structure. This is what it means.
Do you think that it's becoming a little bit overused now as a symbol of representing the essence of something? Or?
I don't think so. I think it has such power, it has such meaning. It explains in a way so much. It tries to visualize what it's about, that it has a profundity that remains with us. In a way, you can never tire of it.
The double helix has travelled a long way from the diagram Odile Crick drew in April 1953. Then, it was an answer to a scientific question. What does the DNA molecule look like? But now, her image is so ubiquitous, it appears that it can mean whatever you want it to mean. Salvador Dali thought it could represent everything he believed about politics and religion. But the double helix has gone beyond art and into consumer products, like neckties and perfume, and it's become part of the language of worldwide advertising. It is, in a sense, everywhere.
What I've concluded from this vast array of uses, and sometimes abuses, is that image that Watson and Crick came up with is so beautiful, so potent, so enduring, that people have come to love it the world over. Like any great piece of art, it almost defies description, gathers meanings and interpretations it never originally had. But its great claim to fame is as a scientific image, not an artistic one. Because against all the odds, it helped us to decipher the incredibly complex science of DNA in one stunning and unforgettable image.